From the perspective of modules, it is not necessarily better to adjust the lifting position as high as possible. In fact, it needs to be adjusted to a reasonable range. When beyond this reasonable range, there are two outcomes. 1. Generate impact and shorten the service life of electronic jacquard machines. 2. The module operates abnormally, resulting in fabric errors. A common mistake is to raise the highest position of the lifting knife as much as possible for the fabric to be normal, resulting in impact and shortening the service life of the electronic jacquard machine. Compared to fabric errors, the impact generated may not be immediately reflected, and may only be reflected a few months, or even years later. For example, new jacquard machine starts working normally, but after a period of time, its working condition deteriorates sharply, and even cannot function properly, or the cost of maintenance exceeds the cost of purchasing the jacquard machine. The electronic jacquard machine has adjusted the height of the lifting knife countless times during its usage time of over 10 or even more than 20 years. That is to say, there are many opportunities that may cause impact. There is now a mature method to evaluate whether there are impacts and quantify them, as shown the mechanical fluctuation on the left side of the figure above. The proximity switch C1 and proximity switch C2 divide the electronic jacquard machine into 4 zones: Zone 1, Zone 2, Zone 3, and Zone 4. Usually, Zone 4 and Zone 1 switch when the lifting knives is in the highest position. Refer to the 4 zones angles in the middle of the figure above. In theory, all 4 zones have mechanical fluctuations of 0%, indicating no impact. In practical work, it is often not always 0%. This is caused by the rapid changes in load during the operation of electronic jacquard machines. Usually, mechanical fluctuations caused by different design files do not exceed 3%. Mechanical fluctuations in one zone often affect the mechanical fluctuations in adjacent zones. For example, mechanical fluctuations in Zone 1 affect mechanical fluctuations in Zone 4 or Zone 2. Usually, we focus on the zone with the highest mechanical fluctuations, identify their causes, and effectively reduce mechanical fluctuations. It is recommended to use free tool software for big data analysis of the real-time online detection data of this electronic jacquard machine. Understand how this electronic jacquard machine evolves from quantitative to qualitative changes, and regularly replace vulnerable parts, such as lifting knives and chains, etc. When mechanical fluctuations suddenly change, it indicates that there may be other reasons, or other vulnerable parts may need to be replaced. Different mechanical structures, cams, sprockets, gears, and other mechanical structures. There are inherent rules that should be taken into account when interpreting these real-time online detection data. Different manufacturers and batches, production time of modules have different requirements for the lifting height of the knife. It is recommended to use modules with the same lifting height requirement for the same electronic jacquard machine. In practical work, the operating speed of electronic jacquard machines also has different requirements for the height of the lifting knife. For example, if the operating speed exceeds 300 RPM, the lifting height should be appropriately reduced. We will provide free technical support. Please send me all the real-time online detection data of this jacquard machine. It's best to send me real-time online historical detection data in bulk through free tool software. I will interpret these real-time online detection data, propose suggestions and work with engineers to solve the current problem with this jacquard machine. In the process of solving problems, we also learn from engineers. Thank you for watching this video. Goodbye.